Assalamualaikum warahmatullahi wabarakatuh and good day guys. In this video we are going to proceed with the next distribution available in our book for Discrete, which is known Poisson probability distribution. Poisson probability distribution has several characteristics that need to be familiar with. In our book, we have 5 characteristics for Poisson. The first one, the experiment consists of counting the number of occurrences of an event over some interval. Right? That interval can be time, area, volume, distance, or any other type of measurements. Next, we have the number of occurrences in one interval must be independent of other intervals. Right, for number 3, there is no limit on the number of occurrences in an interval. Right, the next one, probability of event occurring is the same for each interval. And lastly, average number of occurrences in an interval is known. Those are the 5 characteristics of Poisson. So, example of Poisson random variable that we can have is, for example, the number of car accident during a month. So a month there is the interval for Poisson, and then we have number of major defects in a particular 3 miles highway. So they are talking about major defect on a highway, but the things that make this question Poisson is 3 miles. So the defect for 3 miles, 3 miles and 3 miles and 3 miles, on and off, so on and so forth, that makes it Poisson. Now we have an interval of 3 miles. And then the number of website visitors in 30 seconds. So they are interested in looking at the number of website visitors per 30 seconds. That makes it Poisson. And then number of patients at Unimap clinic between 9 to 12 p.m. So that 9 to 12 p.m. right, makes that range of times makes this question a Poisson case because they have an interval of time there. And then we have number of plants growing per acre. So they want to know number of plants growing in 1 acre each. So basically that makes that a Poisson question. So basically, in other words, Poisson distribution is the probability distribution of the number of successes, x, occurs in a specified time interval or space. So if you have this kind of information that indicate, and the one is to find a probability that indicate for you to use Poisson distribution. So this is how you write down the expression for Poisson distribution. This is how you write down the distribution. X approaching to P naught, capital P naught represent Poisson, and you have a bracket there with lambda inside it. So what does this expression shows? Right, comparing to binomial where you have n and p inside the bracket, this shows that lambda is the only important value that you need to know before we can answer Poisson question. If you know the lambda, then you should be able to solve Poisson question. Okay, so this is the formula for Poisson. You have exponent to the power of negative lambda times with lambda x over x factorial. Okay, so x there will be the value of the questions, the value they want you to look at, right? And lambda that is the average number of events occur in a specific time interval or space of interest. So depending on what is the interest of the question, or the one that want to know the probability, what is the interest of the interval, right? The value of lambda will change accordingly, right? It is not fixed. We are going to see what I mean by that later. So next, let's look on how to look for measure of central tendency and also dispersion for this distribution. So because we only have one value that is important, which is lambda, everything will circle around it. So to look for measure of central tendency, use lambda. To basically mean, use lambda. To look for dispersion, use lambda. Right? So standard deviation, set of the lambda. So let's try to discuss example 2.11 and try to make sure that you are clear on how to calculate lambda Poisson here. So suppose that the average number of car arriving in 15 minute period time is 10 cars. So what makes this question Poisson question? Because it has the 15 minutes there. It talks about car arriving, but per 15 minute period. So that makes it a Poisson case. So find the probability that exactly 5 arrival in 15 minutes. So first, let's try to determine the random variable. What is the variable of interest for this case? So x is the number of cars arriving in 15 minutes. The whole thing, not just car arriving in 15 minutes. Why? Look back at the question. They want us to find the probability that exactly 5 arrival in 15 minutes. So specifically, a car arriving in the interval of 15 minutes is the whole interest. Okay? So, and that is the random variable. Let's look at the expression for this, the Poisson distribution for this question. X approaching to P naught, in the bracket lambda. And what is the value of lambda? Obviously, they giving the average number of car arriving in a 15 minute period is 10. So 10 is the lambda because the interest is for 15 minute interval. So there's nothing that we don't need to change the average number of car value there. So now we have that information. Now let's try to answer the question. We have x equal to 5. So let's look at the formula. So substitute it. Exponent negative 10 times with 10 to the power of 5 over 5 factorial. So calculate it and you should get 0.0378. Okay, and the other way is you can also use cumulative Poisson probability table. So just like in binomial, this table is a cumulative table. So first, before you use this kind of table, you need to make sure you know how the accumulation happens. So how to know that? By looking at the general formula provided at the top of the table. As you can see, for this case, we have x less than or equal to x. In other words, any probability taken based on x in this table is actually consists of a probability that being accumulated from that x and below. Okay, we're going to see what does it mean by that. Right? Let's try to answer the same question, the same example by using table now, and make sure we get the same answer while we, as we calculate manually before, 0.0378. Okay, so let's try to look at this table. So for this table, we need to know two information. First, the x and then the lambda before we can read the table. So for this case, our x is 5, right? And our lambda is 10. So look for 5 and 10 in the table, you'll get 0.0671, which is different from our answer before. Why is that? Again, because this probability is not for 5 alone, it is a probability accumulated from 0 until 5. So that's how you get a different answer there. So how to get back the same answer of 5, x equal to 5, by using this table? We know that we don't need from 0 until 4. So you need to subtract all of those probability out of our answer. So we know that 0.0671 is a probability that is being accumulated from 0 until 5. But we don't want from 0 until 4, we just want 5. So we'll need to subtract the whole 0 until 4. So how to get the probability of 0 until 4? We know that when you look in the table, we at 4, we have the probability of 0 until 4. So 0.0293 there is the probability that we accumulated from 0 until 4. We want to subtract that. So 0.0671 minus with 0.0293 will give us 0.0378, which is the same answer as the one we have calculated manually. Alright, so conclusion. That is important, right? What is the conclusion for this question? So there is 3.78% chance that exactly 5 arrivals of car in 15 minutes. So is it highly likely? Right? Is it 50-50? We can say that it is less likely for it to happen because it is too low. Right? So that is example 2.11. Now let's try to discuss another example, another question. Let's try to look at this question, exercise 2.4 a bit, just to demonstrate on what do I mean by the lambda can change according to the interest of the question. Okay, so we have phone calls received at the rate of 48 per hour at the reservation desk for Regional Airways. So those are the information. It's about phone call that we receive 48 calls per hour, right? 48 calls per hour. So now the question: find and interpret the probability of receiving 3 calls in 5-minute interval. Okay, so we know that the provided information is lambda, right? The lambda, the interval is 48 for 1 hour. So now let's look at the question. What is the question? The question actually have an interest in looking at the phone call received, but now not for per hour, not for 1 hour, for just 5 minutes. So you'll need to actually change the lambda accordingly. 48 is the lambda for 1 hour. So how to get the lambda for 5 minutes? Okay, you do the math, right? So we have 1 hour is 60 minutes. Okay, so let's say we divide 48 with 60, so you get the average for 1 minute times that average times it with 5, you'll get the average for 5 minutes. As easy as that. The same goes for the second question. Change the lambda, right, for the interval of 15 minutes. As for the rest, answer the question just like what we have discussed before by using your manual calculation or table. Okay, so that is for Poisson. Okay, in our next video we are going to discuss about still Poisson and binomial, but now we have one special situation where we are going to use Poisson distribution to answer binomial question. Alright, so till then, thank you.